Hello students, today we are going to start the linear filtering of long data sequence under the chapter of DFT by using the overlap, save and add method. So in real-time application, the input data sequence is very long. It is not possible to do the calculations for such a long data sequence. And this is because the digital computer has the limited memory. So the long data input data sequence is broken into the small length sequence. We can call it as a block or segment of the block. The computation of the each block is done separately, and all processed blocks are fitted after other to get the final output. So there are two methods of such computations, nothing but the overlap save method and overlap add method. So the overlap, let us start with the overlap save method. In this method, the filtering of each block is done separately. Let M be the impulse response of the filter, and here the input sequence is very long. This data sequence is divided into the blocks. That let N be the length of each block. So how to form the different blocks? So different blocks can be divided. So in this method, each block of the length L is formed by taking L samples of the current segment and M minus M samples from the previous segment. So the total length of the block will be N is equal to L plus M minus 1. For the first block x1, suppose x is the are the total number of the samples. So from the x1 is x1 of n, there are no previous segment, that is the first block. So there is a no previous segment block. So this block is padded with the m minus 1 zeros, and the first L samples are taken from the input sequence. So when the input sequence is given, first block should be padded with the m minus 1 zeros. So here zeros are padded, and the L samples are taken from the input sequence. So in this way you will get the first block of the data. Suppose let us take the input sequence 1, 2, 3, 4, 5 minus 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so let m is equal to 4 and l is equal to 5. So m minus 1 is equal to 3. So n is equal to m plus l minus 1. So 4 plus 5 minus 1. So 8 samples are there. So the in first block x1 of n is 3 zeros, that is m minus 1 zero should be pad, that is triple zero, and l is the 5. So first 5 samples should be taken from the input sequence. So 1, 2, 3, 4, 5 should be taken from the first 5 samples of the x1. So now do prepare the x2 of n. So x2 of n is can be performed by take the m minus 1 samples from the x1 of n. So last 3 samples can be taken from the x1 of n, that is 3, 4, 5, and new 5 samples should be taken from the x1 of x of n. So that is nothing but the minus 1, 2, minus 3, 4, 5. So in this way you will get the x2 of n. So that is x2 of n is nothing but the x of l minus m plus 1 up to the x of l minus 1. So that is m minus 1 samples from the x1 of n, and new l samples from the x of n. Similarly, x2 x3 of n will become x of 2l minus m plus 1 up to the x of 2l minus 1, that is m minus 1 from the x2 of n, and new l samples from the x of n. So likewise you can likewise the different blocks of n length can be performed. Now we have the length of each block equals to the n. So that is n should be equal length for the all blocks, and it should be l plus m minus 1. And we assume that the length of the impulse response is n. So this length should be the same as the length of each block n, and this is done by padding the l minus 1 zeros in the sequence h of n. So h of n sequence is n samples of the h of n, and l minus 1 zero should be padded to the h of n to make the same sequence like a n. So endpoint DFT of h of n is h of k. Similarly, endpoint DFT of each block can be computed separately and it is stored in the memory. Let the DFT of mth input block be the xm of k, and now we use the corresponding output by multiplying the xk and x of k and h of k, and let be the output y of k is equal to h of k into x of k. So take the IDFT of y of k. So you will get the y of m is equal to IDFT of y of k. Similarly, the time domain sequence corresponding to the DFT of each input block can be obtained. So how to avoid the loss of the data due to aliasing? Observe the each input block, that is x1 of n, x2 of n. Here the each input block consists of initial n minus 1 samples taken from the previous block, and that means there is a overlap of the sequence, and while last L samples of each blocks are the actual input sequence. So now because of the circular shift of the DFT and because of the overlapping of the input data blocks, there is a aliasing in the initial m-1 samples in the corresponding output block. And to avoid the first m-1 samples, y of n are discarded. So while performing the output or making the output y of n, m-1 samples, initial m-1 samples from the all blocks of y should be discarded. And this means that after computing the time domain sequence, the initial m-1 samples are discarded, and then each block is fitted one after other to obtain the final output. And this overlap save method is described by this figure. This is the input sequence having the L samples. So x of n is can be performed by m minus 1 initial zeros and new L samples from the input sequence. Again, x2 of block can be performed by m minus taking m minus 1 samples from the previous, that is x1 of n block, and new L samples from the next sequence. Again, x3 of n can be performed by taking the m minus 1 samples from the previous one and new samples from the block. So in this way input block can be performed. After the input block performed, this block can be multiplied or matrix multiplied with the h of n. So you will get the y of n. So first, after the performing y of n, first m minus 1 sample should be discarded, and this is your actual output. Again, from the second block, m minus 1 samples should be discarded and new samples should be taken as output. And in the third same block, the m minus 1 sample should be discarded and the output of the y3 will be taken. So finally, output of y1, after that output of y2, and after that output of y3 will be fitted into the line. So m minus 1 samples from the each output can be discarded first, and then output can be performed. So this is nothing but the overlap save method. Next, overlap add method. In the overlap add method, the size of each input block is n, and each input block is formed by taking the L samples from the input sequence, and after the input sequence, m minus 1 zeros at the end of each input sequence can be paired. So in overlap save method, initial m minus 1 samples can be added, but in overlap add method, m minus 1 zeros can be added after the sequence. So this is the x of n can be first L samples taken from the x of n, and then m minus n zeros can be added. So you can make the x2 of n new L samples, and previous m minus 1 zeros can be padded. Again, x3 of n, so new L samples can be taken from the sequence and m minus 1 zeros can be padded. So in this way the input data blocks can be obtained or performed. The impulse response, in impulse response, m samples are given and L minus 1 zeros can be padded to make the length n, and perform the DFT, that is y of m, or convolution y of k is equal to h of k into x of k. Take the IDFT of y, so you will get the samples. So in this way you will get the samples y of n, uh, y1 of n, y1 of 2, so on. So there is no aliasing in the overlap add method. So that's why, because So this is the input sequence x1 of n, m minus 1 zeros are padded, x2 of n from the sequence m minus 1 zeros are padded, x3 of n from the sequence and m minus zeros are padded. This x1, x2, x3 multiplied with the h of n block, so you will get the y of y1 of n, and this output block can be combined added with the next m minus 1 data, again y2 of n, and the output of y2 of n, m minus 1 sample is added to the next block of the m minus 1 sample, so you will get the combined output y of n. So let us take the examples of the overlap same method. Here the x of n is given 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples is given, and h of n is equal to 1, 1, 1. So n is equal to 5. Suppose let consider the n is equal to 5. So we have to perform the or make the blocks of the 5 input sequence having the 5 number of the samples, and hm is given as a 3, so m minus 1 is equal to 2, so two zeros should be paired in every block. So n is equal to l plus m minus 1, so n is equal means 5 is equal to l plus 3 minus 1, so l will become 3. So l minus 1, two zeros with the h of n, so h of n is equal to 11100, so h of n. Now the first block, so this is your input sequence. So first m minus 1 zeros are padded, so 3 minus 1, so 2 zeros are padded, and 3 samples are taken from the x of n, so that is 3 minus 1 0, so total length is 5. Again x2 of n, so m minus 1 previous sample should be taken, that is minus 1 and 0, and new samples 1, 3, 2 are taken. For performing the x3 of n, previous m minus 1 samples are taken, that is 3 and 2, and new samples, that is 0, 1, 2 are taken. Again x4 of n, previous samples 1 and 2 are taken, and new samples, that is 1 is remaining, and the two zeros are padding here. So in this way you will get the x1 of 1, 2, 3 and 4. 4 blocks are available. Now performing the y of k is equal to x of k into h of k, where k is equal to 1, 2, 3, 4. So you will get this output y of y1 of n, y2 of n, y3 of n, y4 of n. So this convolution operation you can use the matrix operation. So x1 of n multiplied by h of n, so you will get this output. Again x2 of n multiplied by h of n, so you will get the y2 of output. X3 of n multiplied by h of n, that is matrix multiplication, so you will get this output. Again x4 of n multiplied by h of n, so you will get this output. So in this way you will get the y1, y2, y3 and y4. So finally you will get this output. So this is the in this system, so m minus 1's first bits should be discarded. So this first bit should be discarded. So output is 322. Next two bits are discarded. So next output is 046. Next two bits, that is 6 and 7, should be discarded. Then the next output will be 533, and again next output should be discarded, that is 431. So from the first block you will get the output 322. From the second block you will get the 046. From the third block you will get the 533, and from the fourth block you will get the 431, and finally you will get the output 322046533 So in this way you can perform the overlap save operation. Next example is related to the overlap add method. So take the same example, 3 minus 1 0 1 3 2 0 1 2 1, and h of n is equal to 1 1 1. So again n is equal to 5, m is equal to 3, m minus 1 is equal to nothing but the 2, and l is equal to 3. So h of n is equal to 1110. Make the blocks. X of n is equal to take the L samples from the sequence 3 minus 1 0, and 2 zeros are padding. X2 of n, next 3 input sequence, that is 1 3 2 and 0 0. Next x3 of n, next 3 samples 0, 1, 2, and next 2 input zeros should be padded. M minus 1 0 should be padded. Next samples is 1, double 0, and 2 zeros are padded. Multiply this input sequence x1 of n, x2 of n, x3 of n, x4 of n with the h of n by matrix multiplication operation, and you will get the y1, y2, y3, y4. So y1 is nothing but 3, 2, 2 minus 1, 0. Y2 of n 1, 3, 1, 4, 6, 5, 2. Y3 of n 0, 1, 3, 3, 2, and y4 of n triple 1, 0, 0. So while performing the overlap add method, you have to add the samples of previous block with the next preceding block, m minus 1 samples of previous block with the next preceding blocks. So the first block output is 3, 2, 2, minus 1, 0, and this m minus 1 sample should be paired with the or add with the next two samples, next output samples. So 1 minus 1 0 and 0 plus 4 4. So you will get the output 3 2 2, and the next samples are the 0 because minus 1 plus of plus 1, so it is a 0, and 0 plus 4, so it becomes 0. So you will get the 3 2 2 0 6. Again this 6 is available as it is. Again these two samples is added with these two samples, so you will get the 5 plus 3. So you will get the 5 plus 3 and these 3 as it is. Again 3 and 2, and this 1 1 should be add. So 3 plus 1 4, and 2 plus 1 1. So you will get, so this one added with this one. So you will get the 3 2 2, next 0 4 6, next 5 3 3, and finally you will get the 3 2 2 0 4 6 5 3 3 4 3. That is finally you will get the output 3 2 2 0 4 6 5 3 3 4 3 1 0 0 by observing this diagram. So you will get the final output here. So what is the difference between overlap save method and overlap add method? In overlap saved method, overlapped values have to be discarded, but in overlap add method, the overlapped values have to be added. In this case, it does not require any addition, but it requires in second method it will involve the adding a number of values in the output. In overlap save method, it can be computed using the linear convolution, and in this linear convolution is not applicable here. Thank you.